Cats, this is Unit 1 Test Review Part 1. I'm going to break this up into a couple of different parts just for time purposes. Let's start with problem number 1 in our review. We're talking about the Subshop and that we've purchased a used pizza oven for $875. After 5 years, the oven is going to have to be replaced, and we're going to sell it for scrap metal for $100 after 5 years. We want to write a linear equation. So what are we trying to do? We're trying to write a linear equation. Okay, and to write a linear equation, we need a slope and we need a point. Okay, write that as, you know, the m equals your slope. A slope and a point. If we don't have a slope, then we can get, if we have 2 points, we can find a slope. And in this case, I think that's what we'll be doing. We're going to try to find the value of the oven over the 5 years or over time. So we're looking for the V over time, the value over time. That helps us know that our X values are going to be time, and of course our V values will be our Y values. So let's look for our ordered pairs. We start at the beginning of time, which we would say 0 time, and our oven is $875. So this is our X, and our Y are our time and our value. Okay, that's how this is set up. This helps us know, this helps us know how to set that up. Next thing we're going to do is we're going to have our, we know after 5 years we're going to replace the oven, and it's going to be worth $100 in scrap metal. So after 5 years we will be worth $100. So again, our time and our value. Alright, we can use those 2 ordered pairs to find a slope. So let's find our slope. That'd be the change in the Y value. So our $100 minus our $875 over our time, which is 5 minus 0. When we divide and simplify that, we're going to get a negative 155. So what does that mean? Over time, every year, our oven reduces by $155. We now want to write an equation. Remember, we're going to be writing in point-slope form a lot, and we have a point and we have a slope. So here's our slope. We can pick either point. If you pick a point that has a 0 in it, it makes your math just a little easier. So that's what I'm going to do here. So my slope-intercept form would be our Y value minus Y. So our Y minus our Y value of 875 equals our slope of a negative 155 times X minus our X value, which is 0. So just X minus 0. That would be our point slope form, and let's go ahead and clean this up and put it in y-intercept form. We would distribute the 155, so we would have y equals 875 equals negative 155x. That's minus right there. And then we would, of course, add the 875 to clear it and solve for y. So our final answer here is y equals negative 155x plus 875. And that's the linear equation representing value over time. We'll change that. Value over time, V of t instead of f of x. Oops. Well, you get that. I'm not going to go back over that. V of t. All right. And that's our first equation in part 1. Go Bearcats. Pause and look at it if you need to. This next problem is about the length and the width of a rectangular garden. And so we have a garden, and there's going to be a walkway surrounding that garden. It asks us first to draw a picture. So let's do that. So we have our garden, and we're going to have a walkway surrounding that garden. What else do we know? We know that the garden measures 15 by 10 meters. So the perimeter would be 15, 15, 10, and 10. So 15 on this side, 15 on this side, 10 on this side, 10 on this side. So that's given information. And the walkway that surrounds us is x wide. So this width right here, oops, sorry about that. This width right here is an x, and this width over here is an x, and this width would be an x, and this width would be an x. And you could do that on all the corners if you wanted. Let's go ahead and look at that. All right, and there's our picture. The next thing we want to do is we want to write the equation for the perimeter of the walkway. So we want the perimeter of the walkway, which means we want this part on the outside, this perimeter. So let's think about what we have. We know that this part of the walkway is 15. We know this little section part of the walkway is x, and this section is x. So that whole length right there would be 15 plus 2x. On the side, we know that this part of the walkway is 10, and we know this part is x, and this part is x, so we would have 10 plus 2x. And if we want the perimeter, we would have 2 of these and 2 of these. So let's write our perimeter formula. So our perimeter would be 2 times that 15 plus 2x. And we would have to add to it 2 of the other side, so 2 times 10 plus 2x. Now let's just use our distributive property and simplify. So 2 times 15 would be 30, 2 times 2x would be 4x, 2 times 10 would be 20, 2 times 2x would be 4x. And so our perimeter would end up being 20 and 30, 4x and 4x. So 4x and 4x would be 8x, 30 plus 20 would be 50. So the perimeter of that walkway is 8x plus 50. I will let you explore on your own if you increase that perimeter by 1 additional meter. Just experiment with that. Instead of being x, it would be 2x, both directions. So this would be a 2x and a 2x, and this would be a 2x and a 2x, which would change these to 4x, 4x, and you could go through that process and compare it to what we found before. I'll find your results interesting when you turn in your review. All right, let's look at number 3. In number 3, we're looking again at an application problem about a company that's making a product, and we have cost and we have sales, and then we're going to figure out what our profit would be. So in part A, it asks us for the total cost of the business, and they tell you that that's the sum of the variable cost and the fixed cost. So we want to write the cost as a function of the number of units. So we want to write C, the cost, in terms of number of units x. So C of x. So our cost function is going to be our variable and our fixed. So our variable costs are going to be $12.30 per unit plus the fixed cost of $98,000. So you need to read through that and make sure you understand that. That means that each unit is going to cost us $12.30 to manufacture, and we had a startup cost for our business of $98,000, whether that was equipment or whatever, that rent, we don't know what that is, or we purchased a building possibly. All right, that's part A. Part B asks us to write the revenue. Revenue is the money that comes into our business when we sell things. So our revenue in terms of X would be, we're going to, every time we sell an item, we're going to sell it for $17.98. That's not what we make because we have to cover our cost, but that is what we sell it for. So that's the money coming in. So it's our income. So we have $17.98 times X. And finally, they want our profit statement. And our profit statement, they even give you on the paper, our profit is our revenue minus our cost. So then we're simply going to take our revenue, which would be $17.98x, and we're going to subtract our cost. Now, we're going to have to put a parentheses because we're subtracting all of our cost. So that would be 1230x plus 98,000. We'll have to distribute the negative, so 1798x minus 1230x minus 98,000. And finally, we will simplify this, and we will get a profit in terms of units would be the difference between 1798 and 1230, which is 565x. Minus our 98,000. Minus our 98,000. All right, go Bearcats, and that would be that way we could figure out how many units, how many x values, how many units we would have to make before. Oh, that's 98. Before we would make a profit, before we'd make any money. It's a lot. It looks like. You let me know and circle it on your review. Okay, in number 4, we're asked to find the slope-intercept form of the equation passing through the given points. Let's go ahead and write it in point-slope form first, and then we can change it to slope-intercept form. So if you will graph or sketch first, sometimes it can save you a lot of time. So let's take a little sketch here. If I'm at 0, 0, and then I'm at 0, 10, and I connect those, I have a vertical line. If I have a vertical line, I believe we have an undefined slope, so we have an undefined line. Well, not an undefined line, but an undefined slope. So that means that our value is going to be an x equals equation. So if we're writing the equation, that's going to be x equals 0. Because when x is 0, y can be any value. And that is an undefined term. Let's just, for grins, let's say if we switched it. What if we had 0, 0, and 10, 0? Let's look at that sketch. So we have 0, 0, and then we have 10, 0. That would be a horizontal line. Oops. The horizontal line would have a defined slope of 0. So the slope would be 0, but it would be a y equals 0 equation. All right, that's just some knowledge for you. All right, let's go on to B, and let's look at what that would look like in a sketch. We have a -1, 4, and we have a 2, 0, and so our line's going to look something like this. We know we're going to have a negative slope just by looking at the line. And to write the equation, we need a slope and a point. Well, we have 2 points to choose from, and remember I told you if you use a point, there's a point with a 0, I would always use that. That makes it a little easier. Now we do need to find the slope, so let's find the slope. Change in y, so 0 minus 4, and the changes in x's. 2 minus a -1 would be +1. That's going to give us a -4/3 as our slope. So point slope form. Remember, we're going to set this up. Our slope goes here. And we would have y minus our y value, which is 0, and x minus our x value of 2. So we have y equals, this is going to come out really easy. Distribute the 4/3, so you get a -4/3 x, and distribute the 4/3 to the 2. And this is where some of you get confused. You're multiplying -4/3 times -2/1. So think about it that way. -4/3 times -2/1. You're multiplying straight across. So -4 times -2 is +8, and 3 times 1 is 3. So +8/3. That would be your slope-intercept form of that equation. Hopefully that helps you. Go Bearcats. Okay, in number 5, we're also asked to write the slope-intercept form. We're going to start with point-slope form since that will be easier for us. And we're asked to write the equation of a line that is parallel to this line and perpendicular to this line, and both go through that point. So parallel and perpendicular, we would need to know first the slope of this line. Oops. So we can compare the slopes. So to do that, let's just solve for y. We'll move the 5x over, and we have -4y equals -5x plus 8. Then we divide by -4, divide by -4, and divide by -4. And we get y equals +5 x minus 2. All right, the slope of this line is 5/4. If we want a line parallel, our parallel slope would be the same, 5/4. If we want a line perpendicular, a perpendicular slope would be -4/5. So these are our two slopes we're going to use, and this is the point we're going to use. And let's just do point slope form. So for our parallel line, I'm just going to use a little symbol for parallel, we would have y minus a -2, so +2, equals our slope of 5/4 times x minus 3. Go ahead and slope-intercept form, we're going to distribute. And we would have y plus 2 equals 5/4x minus, okay, put that 3/1. 3 times 5 would be 15. 1 times 4 would be 4. And then we need to subtract 2. So y equals, all right, this is where you're going to get a little confused. We have 5/4x, and we have, I'm going to go to the side over here. We have -15/4 minus 2. But to make 2 and 4, we multiply the bottom by 4, and we multiply the top by 4. So -2 times 4 would be -8. So -8/4. -15 and -8 would give me a -23/4. So -23/4. -23/4. And that would be our slope-intercept form of our parallel line. Now let's look at the perpendicular line. Very similar. We're going to use the same point, so we're still going to have y plus 2. But this time our slope would be -4/5 x minus 3. So let's do this one, distribute. So we have y plus 2 equals -4/5 x. Put the 3/1 and multiply the top. So -4 times -3 would be a +12, and 5 times 1 would be 5. All right, we're going to subtract the 2 from both sides. So y equals -4/5 x. Now, let's go and look at this part right here with these fractions. You will have a scientific calculator that might help you, and you may use that, but I'm going to show you algebraically what to do. So we have 12 fifths, and we're going to subtract 2. Well, we want it to be fifths, so 2 times 5 would be 10. So 10 fifths is the same as 2. We have 12 minus 10, which would be positive 2, so plus 2 fifths, and that would be your perpendicular line. I will give you a blue calculator, so that will help you some. Go Bearcats! All right, for number 6, we have, it's a little bit of a tricky problem. We have the value of a product was $12,500. The value of product in 2006, I'm sorry, was $12,500. What we don't know is what the value was in year 0, and we also don't know, we're trying to predict the value in 5 years. So what we do know is in year 6, the value was $12,500. Now, what we're going to have to do is we know that the value of this item is increasing by $850 a year. So back, we could subtract $850, for 5 years and go back to 0, or we can incorporate that in our problem. So we're trying to find the value over time again. We know it's increasing by $850. But you can't just say 850x since x does not represent 0. X represents 6. X represents, or time represents 6. So we're going to have to say x minus 6 because we want to know what happened at year 0. And that's really tricky. If it were year 3, you'd put minus 3. You're going back to year 0. And we're going to add to that 1,200 because currently, in the current year, it's worth 12,500. 12,500. We're trying to get an equation in year 0 what it was worth. And this will give us the equation between year 6 and year 11 we're going to be predicting. So when we distribute the 850, you get 850x minus 5,100 plus your 12,500. And our value over time, when we simplify, then is 850x, increasing by 850 each year. And we're going to say plus 7,400. So if we were in year 0, it was worth 7,400. If you plug in 6 here and you multiplied and add to 7,400, you would get the 12,500. And therefore, you'd be able to predict in year 11 what would happen. All right, so 5 years after year 6 would be year 11. You could plug in and you would be able to predict what that would be. Go Bearcats. All right, the last one on this one, then I'm going to cut it off and we'll do a part 2 video, which will be 8 through 13, is number 7. 7 asks us to determine whether y is a function of x. Y is a function of x. They give you 2 equations. They give you 16, part A is 16x minus y to the 4th equals 0. And part B is y equals the square root of 1 minus x. 1 minus x. Well, first of all, most of the time when we know by looking at a graph what the picture is. Most of the time we see things happening with our x values, x squares, x cubes, x to the 4th, not with our y values. Often when things occur with the y values, often that graph has been rotated or moved on its side, and it does not become a function. But let's go ahead and solve it so you can see what happens to that. So we're going to solve this by we're going to move the y to the 4th to the other side. So we would get positive y to the 4th equals positive 16x. We would take the 4th root of this. When we take the 4th root of this, we would get y equals, because we took an even root, it would be positive or negative, and we could make that the 4th root of 16x. Now, if you want to make that 4 times the 4th root of x, you can, but it doesn't really matter. What you need to know is that this graph all of a sudden is going to look like this. How do I know that? It's because of this positive and negative out here. Because if I put a 1 in there, the 4th root of 16 would be 2. And that would make it a positive 2. So at 1, I'd be at positive 2. If I put a negative 2 in there, I'm sorry, if I put a 2 in there and I get 2, it'd also be a negative 2. So your graph is going to look like this, would not pass the vertical line test, so this is not a function. So this is a no. All right, part B, is this equation right here. So y equals the square root of 1 minus x. Well, first of all, you could simply just know what that graph looks like. Okay, so you can actually create a t-table if you wanted. If I plug in a 1, what is my restriction? I can't have any negatives underneath there for 1. So if I plug in a 1, I'm going to get a 0. If I plug in a 2, I'm going to get a negative, so I can't do that. So I'll plug in a negative 1. So if I plug in a negative 1, I have 1 minus negative 1, and that's going to end up being a positive, so that's going to work. Not a really pretty root, so let's pick something like a 3. So if I plug in negative 3. Negative 3 is 1 minus a negative. That would be a positive 3. So 1 plus 3 would be 4. The square root of 4 would be 2. So at negative 3, I would be at 2. And at 1, 0. And if I plug in a 0, I would be at 1. Sorry, I don't have my graph done very good. Let me see if I can fix that. So at 1, we're 0. At 0, we're 1. And at negative 3, we're 2. And your graph would look something like that. Definitely pass the vertical line test. Plus, it's just a y equals graph, most of the time a function. Go Bearcats. All right, I'm going to go and close this one up, and we'll have part 2, so look for part 2 online on YouTube.